Welcome back, Finxters. Now, this is the second part of our question wherein we had to find the k closest numbers in a sorted array. If you have not gone through the first part of this lecture, I highly recommend you to have a look at that lecture and then move on to this one. I have explained how the question works there, and then I also went on to explain you the easier approach to solve this question. In this lecture, we are going to see how we can solve this problem in a more efficient way. Now, if you remember, in the previous approach, we used two different functions and then we reached the output. The first function was used to find the insertion point using binary search, while the second function was used to find the k closest numbers. Now, the better way would be to combine both those methods and generate an optimal solution. Thus, the main idea of this algorithm is to find out the lower bound of the given range k. Even in this algorithm, we are going to use the left, right, and the mid pointers. However, in this case, the numbers that are between left and right pointer are the candidates of the lower bound. Hence, without discussing a lot of theory, let us dive into an example which will help us to understand how this algorithm works. Now we are using the same example that we used previously. Here the value of x is 15, the length of the array is 6, and the given value of k is 4. This means we have to find 4 closest numbers to 15. Now initially we need our left and the right pointer. Thus, the left pointer is once again going to point at the starting index of the array, which is 0. However, there is a change when it comes to the right pointer. Initially, the right pointer is going to point at the index which is given by the length of the array minus k. So this means the length of the array in this example is 5 and the value of k is 4. I beg your pardon. The length of the array is 6 while the value of k is 4. So we subtract 4 from 6 and that is 2. This means our right pointer will initially point at the second index. So now we have our left and right pointers. Now once we have initialized these pointers, it is now time to iterate through the elements in the array in order to reach the output. Thus, how long do we iterate? We are going to perform the iteration until left is less than right. Thus, this means that as long as the left pointer points at an index which is less than an index which is pointed by the right pointer, we are going to perform the operations again and again. Now, don't you think that something is missing in this diagram? We have two pointers, but if you remember, we also need another pointer that was mid. So we also need to find the value of mid. And now how do we find the value of mid? To find the value of mid, we will simply add the values pointed by the left and the right pointer, and then we divide the result of the addition by 2. Now remember, this is going to be an integer division. So this means in the first iteration, we are going to add 0 and 2 and then divide it by 2. So that would be 1. Hence, mid points to the first index in the first iteration. Well, we now have all the 3 pointers at our disposal. Now, as soon as we found the mid pointer, this is going to help us in our approach. Now, let's see how. We are now going to work upon a certain window. So as you can see, the orange box on the screen marks the window which we are going to play around in every iteration to reach our output. Now it is this window which we are going to shift left or right and either shrink or expand it, and that will help us to find the lower bound which is the output. Now things will be more clear as we move ahead with this algorithm. So let's see what's the condition that we need to define in order to compute the lower bound. Now, in this case, the condition is quite easy. We simply have to check if x minus the value pointed by the mid pointer is greater than the value at the mid plus kth index minus x. Now, this might look confusing, so let's have a look at the example itself. We simply subtract 15 minus 10. That is, x is 15, while the value pointed by the mid pointer is 10. So 15 minus 10, which is 5. And then we check if it is greater than the value at the mid plus kth index. So mid is 1 plus 4, which is 5. So that is 20 minus x. So that is 15. And that again comes out to be 5. Now, since this was the first iteration, you didn't understand the importance of the window that you can see on the screen. But if you look closely, then you'll find that the value at the start index of this window and the value at the end index of this window are used to compute our condition. It was simply 15 minus 10 and 15 minus 20, which in this case is 5. That is, the result of both the computations was 5. So this condition is now false. Now, as soon as this condition is false, we then play around with our right pointer. That is, the right pointer will immediately point at the mid index. Let me repeat it again. If the condition evaluates to false, then we make the right pointer to point at the index of mid. Now this means the right pointer in the first iteration will point at 1. It was initially pointing at 2, but now since the condition is evaluated to false, it will now point at 1. So let's have a look at that. Okay, now there's the calculation for you on the screen. I purposely did this so that things become clear and you are able to understand the kind of calculations that are going on. 15, which is the value of x, minus 10, which is the value at the start of the window. And then we check if that value is greater than 20 minus 15, where 20 is the value at the end of our window. Now let's see what happens to the right pointer. And there we go. The right pointer now points at the mid index. Now that was it for the first iteration. It's now time to move on to the next iteration. And we once again check, is left less than right? And we find that yes, left is indeed less than right because left now points to 0, whereas right now points to 1. So we move inside our while loop and then we again compute the value of mid. So how do we compute that? We simply add the values of the left and the right pointers, which is 1 and 0, and then we divide it by 2. So 1 divided by 2. Since we are doing an integer division, the output of this is going to be 0. Now please keep in mind that we are doing an integer division here. That is why the value of mid will now be 0. So let's have a look at that. And as you can see, mid will now immediately point at the 0th index. Now it's time to shift our window. So let's see what happens to the window. And as you can see, the window shifts to the left. So if you have a close look, you will find that the range of this window is mid. That is, it is starting from mid and then it ends at mid plus k. So mid is 0 and mid plus k, that is 0 plus 4, is 4. So that's how we are using the window in our calculation. If you have a look, x minus 0, which is the starting point of our window, and then we are also calculating 4 minus x, where 4 marks the end of our window, and it is given by mid plus k. Now let's quickly have a look at the calculation that takes place. And as you can see, we simply subtract x, which is 15, minus 8, and then we check if that is greater than 18 minus 15. So we are simply checking, is 7 greater than 3? And now in this case, the output is true. That is, the output of the condition is true. So instead of shifting our right pointer, we will now shift our left pointer such that now it will point to the index which is just beside the mid index towards the right. And at this point of time, mid and left both point at 0, and mid plus 1 is going to be the first index. So left will now point at the first index. Let's have a look at that. And as you can see, left will point to the first index. Now what does this mean? This means that we have come to the end of our iteration. And why so? That's because if you see, right and left both point at the same index or the same value, which is 1. And now you might be wondering, but how did this help us to reach the output? To answer that, you have to look closely on the screen, and what you'll find is that if you think logically, the output should be 10, 12, 15, and 18. But that is what we are calculating. How will our program calculate that? Our program will calculate the output by simply finding the values that are between the index pointed by the left pointer. So what's the index pointed by the left pointer? It's 1. And what will be the range? The range should be 4. So since this is a list, we are going to slice it. And can you tell me what's going to be the value of left plus k? So if left is 1, then left plus k is going to be 5. Yes, I hope you got that right. So if we slice the array or the list in this case in the range 1 to 5, then the indexes that will be included are 1, 2, 3, and 4. So I hope you know how to slice a list. Now, since you are going to appear in an interview, it is considered that you know to slice a list. So let's try to visualize what I was trying to explain. And there we go. As you can see, we sliced the list such that the first index, which was 1, or the value at the first index, which was 10, was included, while the value given by the upper bound, that is left plus k, was not included. So the output is 10, 12, 15, and 18. I hope you understood how we are using the pointers and the window to calculate the range of our output. We are iterating until left is less than right. And as soon as this condition is not satisfied, we know that we have found our range, which will help us to deduce the answer or the output, which is given by slicing the list from the left index until the left plus kth index, such that the left plus kth index will not be included. Now, if you are confused with this slicing, I highly recommend you to go ahead and learn how slicing works and then come back and try to understand how I sliced the list. But I'm quite sure that you know how to slice a list. So I hope that you understood this solution. Hence, without further delay, let us move on and have a look at the code. That's the code that is going to implement our algorithm, and it is doing exactly what we learned previously. That is, initially the left and the right pointers point at the indexes 0 and the index given by length of the array minus k. So this means if the array had a length of 6, then left would point at the 0th index while right would point at the index given by 6 minus 4, which is 2. Now here 4 is the value of k. Okay, now we move inside our while loop. And how long do we iterate? We iterate as long as the value of the left pointer is less than the value of the right pointer. And then inside our loop, we calculate the value of mid. And if you remember, we are doing an integer division. Now let me clarify this to you properly so that you understand the concept. Let's see what happens when we do an integer division, and let's also try and find out what happens when we do a float division. Okay, let's execute this code. Before that, let me comment this out. Okay, now let's execute our code, and there we go. As you can see, in the first case where we did an integer division, the output is 0. Whereas in the second case where we did a float division, the output was 0.5. I hope this makes things clear. Now let's move back to our function and let's see what happens within the loop. We check if x minus the value pointed by the mid pointer, and if you remember, this was the value at the starting point of our window. And then we check if this value is greater than the value at the mid plus kth index minus x. And what was mid plus k? Do you remember? Yes, it was the end index of the window. So if this condition is true, we shift our left pointer such that it points at the index given by mid plus 1. That is the value which is exactly one more than the value of mid. And if this condition is not true, in that case, we make the right pointer to point at the index of mid. This goes on until left is less than right, and as soon as left is no longer less than right, we come out of the loop and then we slice our list to return the output. Now let me quickly go ahead and clarify this to you, like how slicing happens. Suppose we have a list which has the values 1, 2, 3, 4, and 5. And now we are going to slice it, or let's say the values are 0, 1, 2, 3, 4, and 5. And now we are going to slice it such that we will be slicing the values from the first index until the fifth index. So let's do that. Let's print li and then let's slice our list. And then let's say we are going to slice from the first index until the fifth index. And what do you think should be the output? Yes, the output should be 1, 2, 3, 4, and no, you're right, 5 won't be included. That's because the first index is included. However, the end index within the slice operation is not included in the answer. So let's execute this and check. And as you can see, we have the expected output. So I hope you now have a rough idea about what we are trying to return in this case. So that was it. And I hope you found it easy as well. But trust me, even though that this code looks small and is definitely going to be more efficient than the previous code, but this is not something that will occur to you at once. Though the previous code was lengthy, but that was something you had implemented before. You had already performed binary search. And then once you found the insertion point with the help of binary search, you simply had to find the k closest neighbors. But in this case, you had to deal with both the functionalities together. But I hope after I have explained this is not going to be a big issue and you can quickly solve this problem if it is presented to you in the interview. It's now time to quickly go ahead and check the test cases and let's find out if our algorithm works. So these were the respective test cases. Let's go ahead and check if we have the expected outputs. So this is the input array. This is the value of k. This is x. And then we call our k underscore close function, which does the computation for us. And this is the expected output. So let's check if this works. Okay, we have the correct output in the first case. Then we again have the correct output in the second case as well. And now in the third case, we have the correct output as well. Finally, in the fourth case, we have the correct output again. So this means our algorithm works perfectly and we can definitely use it. Now, how is it more efficient in terms of runtime complexity? So if you remember, the previous code had a runtime complexity of log n plus k. However, this code will have a runtime complexity of log n minus k. And now instead of showing you how that happens to be log n minus k, let us try and find out the number of iterations that our program undergoes with the help of an example. Once we visualize that with an example, things will be clear and we'll definitely know why the complexity of this code is log n minus k plus k. So before calculating that, let me write down the complexity for you so that we can cross check it later. So let's say we have counter variable and we initialize it with the value 1. And now let's keep a count of every iteration. So let's print counter and then let's increment the value of counter by 1 at every iteration. So this will help us to compute the value of count at the end of every iteration. Thus, we will get to know the number of iterations that our program undergoes. So this is the example and this is the input array. So the length of the input array is 6. So this means n is 6. Rather, I would say let's take a higher value because that will help us to understand the calculation better. So let's say we have not 6 but 11 elements in our array. So let's say 21, 25, 26, and 28. So how many elements do we have now? So I guess we have 10 elements. So let's go ahead and add two more elements. Let's say those are 29 and 30. Okay, so let's say we have 12 elements. Now let's go ahead and execute our code and let's find the number of iterations that we have to go through in order to reach the output. As you can see, the number of iterations that we had to go through were 4. So this means that the number of elements were 12 while the number of iterations were 4. Now let's do a quick calculation and let's find what's the log of 12, which is the value of n, minus k, which is the value of, which is 4. So that is log of 8, which is 3. Now 3 is roughly equivalent to 4 when it comes to time complexity computation. Let's have a look at another example wherein let's take the value of n to be 11 and let's say the value of k is 3. Now let's go ahead and let's check. Before that, let me reduce one element from our array so that we have n elements, that is 11 elements. Now let me go ahead and execute this code. And as you can see, we now have 3 iterations. So now let's do the calculation. So let's see what happens. Log of n, which is 11, minus k, which was 3 in this case. Let's cross check that. Yes, it was 3. Now this again is 8. And once again, log of 8 is going to be 3. So we can safely say that our while loop has a complexity of log of n minus k. And now when we return the output, we need to slice the list. And since we are slicing the list, the complexity becomes k in this case. So what will be our total time complexity? The total complexity is going to be log of n minus k plus k. So I hope now you understand why this is the case or why this is the time complexity. And this complexity is definitely slightly better than the complexity of log of n plus k. When the value of n is large and also k is large, then it is going to make a considerable amount of difference in terms of complexity. So, yes, if you put forward this algorithm and this code, it is definitely going to impress the interviewer, and I hope you'll definitely get hired as well. So, that was it for this question, and I hope if you come across this question in your interview, you can definitely solve it.